Hi, I'm Scott Hunter, the Director of Program Management at Microsoft on the .NET platform, and I am so excited to be here today to present at CodeGarden. I joined Microsoft back in 2007 on the ASP.NET team, working on products that you're all familiar with, things like Web Forms, MVC, Web API. Then in 2010, my group got lifted out of developer division, and we moved into Azure for a couple of years, making sure that ASP.NET worked great in Azure. We had great tools to publish your applications from Visual Studio to the cloud. And then I got lucky and had the ability to come back to developer division in 2016 as we were working on a project that started off being called ASP.NET 5, and then it became .NET Core, and then it became .NET. And so let's chat about where we are on our .NET journey. Now, first off, .NET is an amazing platform. You know, when we first started building it back in 2002, we primarily focused on building desktop and web. But as you can see here, as the world changed in 2010, when we moved into Azure, we added the cloud to the platform. In 2016, we purchased Xamarin. Xamarin had some tools for building iOS, Android applications using .NET. Then we have things like Unity. If you ever play a game and it shows it's powered by Unity, it's actually powered by .NET. And then with the advancements that we did with .NET Core, supporting more architectures and platforms, we were able to add IoT as a place that you can run .NET in. In fact, many people would be surprised to know that if you have a Samsung television, the operating system of that Samsung television is running .NET. And then finally, we took some AI technology we had at Microsoft, and we rebranded it a couple of years ago into ML.NET. And so, you know, we think we're one of the broadest platforms for building all these types of applications using .NET. Now, you know, .NET's old. I mean, we shipped the first version in 2002, and now we're in 2021. How are we doing? People always ask, is .NET still growing? Answer is yes, we're still growing. We have over 5 million users using .NET and our tools. On the Stack Overflow developer survey, we've been the #1 most loved framework 2 years in a row in 2019 and 2020. If you look at the velocity of a project on GitHub, the Cloud Data Foundation does a monthly check of this, and .NET ends up being the #1 project in GitHub with the most velocity. That's measuring the number of PRs, the number of issues, the number of comments, all those things add together. And we only open sourced .NET in 2014, so it's made us really, really happy that the open source has picked up as good as it has. We're also the #5 language on GitHub as well. If you look at raw performance, which is something we really push on in .NET, we are 10 times greater in performance than Node.js. And then as we look at the new customers that come into our pipelines, 40% of them are students. And so we hope this is going to bring a new generation of .NET developers along with us. Let's talk about performance. Here you can see on this slide where we're using the Tech and Power benchmark. That's not even a benchmark that we run ourselves. We do run a copy of it ourselves, but it's run by an independent company, and they run and produce the results of this on a regular basis. And what you're seeing here is .NET at 7 million requests a second compared to 2.1 million requests per second for Java and under 1 million requests per second for Node.js. This is the plain text benchmark. It's not the best benchmark, but it does show the commitment we have to performance. And I'll talk about some of the other benchmarks in a second. Something else is, you know, we added something called gRPC in .NET a few years ago. And gRPC in many ways is very, very similar to WCF, except it is cross-platform technology. You can have a .NET server running gRPC, and you can call it from any other language, and vice versa. You can call any gRPC using .NET the same way. Now, if you take gRPC and we look at the raw performance, again here's a benchmark. The URL at the bottom kind of shows where these benchmarks come from. This is also an independent benchmark, and sadly it was run before we actually shipped 5.0. We think we might have caught rust by the time we RTM'd, but we haven't seen this benchmark run again yet. But you can see here, you know, if you're using a modern cross-platform, you know, messaging stack like gRPC, we're faster than Java, we're faster than C++, we're faster than Go, and we're barely slower than Rust. And I said this was on a pre-production version of .NET 5. And this is all about what we care about, performance. We want your app to be the fastest on our platform. .NET adoption. This is amazing too. .NET Framework was this big thing that gets installed as part of Windows. And one of the challenges we've always had with .NET Framework is many of our customers stay on older versions for a longer time. With the newer .NET Core and .NET 5 Plus, we are seeing people adopt .NET at a faster rate than ever. You can see in the first 6 months of release, .NET Core 3.1 had 3 million people using it already. If I look at .NET 5, in the same time frame, we have 3.6 million people using it. So people are adopting and moving to the new tech faster and faster, and that's what we want. We want you to be on the latest, best tech, as fast as possible. So what is .NET 5? If you look at that animation, I showed how we had, I'll go back and run it one more time. There's .NET Framework, .NET Core, Mono Xamarin. We're trying to collapse all these things down into what we call a single unified platform. We give you flexible deployment. This is one of the things that is super important with Core and .NET 5 is it's not part of the operating system. And by not being part of the operating system, now you can control when to put it on the machine. If you put a new version of .NET on the machine, it will not break the existing applications that are using an older version of .NET. So we give you the full control for the first time ever. I showed earlier some of those perf slides, unparalleled performance. Really, that is our goal. It's part of our culture of our team now, is to keep making .NET faster and faster every iteration. And then by being faster, that means if you host your application in a cloud, it's going to cost you less money because the app is running so fast. And then we're always, taking our languages and our tools and our APIs and keep innovating there. That's a big goal of the team. Now, I'm really excited about this. This is something we announced in February. It's called the .NET Upgrade Assistant. And the goal here is, we know a lot of our customers have applications, maybe a WinForm or WPF, an ASP.NET MVC application. There's lots of old code. And we really haven't had any tools to help you move your code forward. But I'm happy to say we are working on a tool right now. We plan to ship it in RTM the same time we ship .NET 6. And literally what you do is you run it from the command line, and it will upgrade your application as best it can. It's not going to fix everything. And let's do a quick demo of that real quick. So I'm going to switch to my Visual Studio here. And I've got this application that Scott Hanselman on my team wrote years and years ago called Baby Smash. And if I come look at this and I right click and I see the properties, this is obviously targeting .NET Framework 4.6.1. And so, but I want to move this to the newer tech. I want to move it to .NET Core. How can I do that? So let's go and open a terminal prompt here. And what I can do is I will show you this. Here you can see I've got the Upgrade Assistant right here on my machine. How did I get that? If I go to my browser, you can see we have a whole page here on how to get started to use the tool. You basically type this command line in here, right, from any prompt, and we'll install the global tool. That's what's showing up here on my screen. And then all I've got to do is run that. And it's going to want a project. So let's do upgrade. And let's do Baby Smash. Let's do the SLN. And now it's going to do a couple things for me. The first thing it's going to do is it's going to go ask me, do I want to actually back up my existing project? In my case, I don't really care about backing it up because I just got it from GitHub. I don't need to back it up. So let's skip that and press enter. The next thing it's going to do is convert my project file. We have a new project file type for .NET 5 and .NET Core. And so now it's going to go and upgrade my project file for me. There it goes. Okay. And next, it's going to go clean up my NuGet package references. And what that means, it's going to go find, if I'm referencing old packages or the wrong packages, it's going to do its best to go and fix those. Then it's going to update the TFM. That's the target framework moniker. That is the thing in the project file that tells us which version of .NET we're using. It's going to make that go to .NET 5. There we go. And then it's going to go and upgrade any of my NuGet packages that are necessary. Here we go. And you can see it added a Microsoft Windows compatibility package. That's a package that brings some of the older parts of .NET Framework into .NET Core / .NET 5. And then you can see next what it wants to do is it's going to change and update my my config files. And then as we've actually at Microsoft gone and helped people move their applications, there are some fixes that we can do in your source code that we know about. And so you can see here, it's going to apply a fix in my source code for me. And now basically I want to finalize the upgrade. And I'm done. So let's go and go back to Visual Studio. And it's going to notice that things have changed. Let's say reload the entire project here. Okay, so now I'm going to, once again, it's not magic. It's not going to fix everything. But let's do a build and let's fix whatever's broken. Okay. So it's basically saying this namespace doesn't exist. It's because when we ported Click Once into .NET Core, we didn't bring all of it. We brought the parts that people use the most. And so there's some stuff that is not here. I just need to comment a little bit of this stuff out. Let's fix that. Once again, per what I was saying before, these parts of Click Once are not in .NET 5. So let's comment this out too. Just take that away. I already know this one's going to be a complaint as well. Let's take that away. You might not like that one either. This code, we don't need anymore. Same thing here. I think I'm almost done. I think that might have been the last one. There you go. One more I missed. And we'll take this out. And there we go. Now let's run the application. And here is Baby Smash ported to .NET 5. And what? It took me a minute or two to go and port this application. So we're super excited about this. Please try it and use it on your projects and give us feedback. Next thing, let's talk about .NET 6. This is what I've been calling this the unified version of .NET. Over time we've tried to unify all of our tech. We want every project to use the exact same SDK. You'll download the .NET 6 SDK. From that, you can build mobile, you can build Windows, you can build ASP.NET, all from one SDK. We want one BCL. You might not be aware of this, but if you run a Xamarin project today, it's actually running on the Mono BCL, not the .NET Core BCL. So with .NET 6, all of our project types will all use the exact same core BCL, and they'll all use the same toolchain. You can do .NET Build, .NET Run, all from a command prompt. We're going to have awesome cross-platform native UI. This is the Xamarin Tech, which will let you build iOS, Android, Mac, Windows apps. One code base, all those types. Awesome cross-platform web UI. This will give you, ASP.NET, whether it's MVC, whether it's Web API, or it's Blazor, you get all of that. We've been working on cloud native. That's when you think of containers and microservices, and Docker, and all this kind of stuff. We keep investing here, and I'll show some of that. And then once again, every release of .NET gets faster, and so there'll be more of these productivity releases. And I believe that after we ship .NET 6, we're going to have the best breed solution for all modern workflows in our one platform. Now, let's talk about some of the big features that we have in .NET 6. Simplify and write less code with C#10. You can basically build an API in .NET in about 3 lines of code now. We have some new features like global usings that get rid of all the usings. We have some new ways of removing some of the typecasting around lambdas. A lot of good stuff there. .NET multi-platform app UI, or .NET MAUI, for letting you build native mobile and desktop applications. Xamarin, we did iOS and Android, and now we've added Windows and Mac to this as well. Blazor, you can now take a Blazor app and put it into a desktop app. Basically, you're putting Blazor into MAUI, and this lets you actually have a web app. You can still use web tech, but because it's actually running in a native app, it can actually still use all the resources and all the stuff on the actual local machine. Minimal web APIs. This is one of these areas we've been focusing on, removing the amount of code you have to write to build an API. More device targets, including the M1 chip from Apple. We also have WinForms and WPF on ARM64 for Windows and single file exes. And then obviously this next one's, I think, the biggest feature we have, which is hot reload. We want to make it faster for you to write your code. And with hot reload, you don't have to run something, then stop, and then run something and stop. You can actually keep making changes to your application as it's running without even attaching the debugger. And so lots of good stuff coming in 6. Let's talk about one of the big things in 6 that's coming as well is Entity Framework Core. It's one of the areas we've really worked on performance. And you can see compared to .NET 5, EF Core is 70% faster than it was before. And this is tons of optimizations inside of EF Core. It's 31% faster query performance and uses about 43% less memory, which means once again, your app's going to use less memory. And so it almost is on par with Stack Exchange's Dapper library, which is a lightweight ORM library for .NET. And now you can get all the power of EF Core and get the same kind of performance you would get with Dapper. Super excited about this. This is showing some of the new stuff that we have in C#10. You can see at the very top here, global using system. You can reference this and then not have to reference it all throughout your entire application. Improvements to lambdas and auto properties. The lambda thing, you'll see that in a second on one of the API things. And this is going to ship in .NET 6. Super excited about C#10. This is minimal web APIs. And so this is, when people look at our technology was built for enterprise-grade applications. And because of that, our tech can be complicated. You've got multiple files. Many people told us, in an MVC application, where do I write my first code? If I want to build a web API, I need to have controllers and all that stuff. So we're not going to replace any of that. That still is awesome tech. But we do want to have lightweight ways for you to build your applications. So in this case, this is a web API. It's 3 lines of code in a single file. Notice that it's low ceremony. It's a top-level program, which means it doesn't have a program or a main or any of that stuff. We just know to run your code. It's also using global usings here, so you don't see any usings here. And if you want, you can start here. But if you need controllers, because you're going to have lots of APIs, it's always going to be an option as well. So you can basically move forward, and this will ship in .NET 6. And what I want to do now is I'm going to do some demos, and I will tell you right now, when I'm doing the demos are actually videos that I recorded, and that's primarily because as we started doing these demos, we still have not shipped the next version of Visual Studio that enables some of the C#10 features and some of the .NET MAUI features. It should be coming out any day now, but because of this, I had to record these on different machines to make them work. So let's do this.
I am super excited to show you ASP.NET Minimal APIs. We first introduced Web APIs in .NET back in 2012 with the Web API project, built on top of MVC, which uses controllers, routing, attributes, conventions, dependency injection, and more to let you build enterprise class APIs on .NET. And we've carried all that technology forward to .NET 6. But we see a new trend around lightweight APIs and small microservices, and some new frameworks like Express in Node, Lumen in PHP, Fast API in Python make these super easy to build minimal APIs. We want to enable you to build the same lightweight APIs using the same ASP.NET that you know and trust, with less configuration and a path to upgrade to controller APIs if needed. To do this, we're using a bunch of new technologies. Look at this application. Using top-level programs, there is no class or main. It's just code. Using a Lambda, I can write the function in line next to my route. And if I run this, you can see that my 3-line application can return hello world to the browser. We think these new lightweight APIs are going to make it easier for you to build microservices. We think it's going to make it easier for new people to learn and build their first APIs in .NET. So I'm super excited about this. But I want to take this to the next level and show you a real API. So let me go back to Visual Studio. Here we are back in Visual Studio, and in this case I've got 3 API projects. My minimal web API project hosted in Azure that powers the rest of the demos you'll see today. I've got my MVC web API project here as well, and I've got an Express application written in Node. Let's start off with the MVC web API. And you're going to see it's got a bunch of files, startup.cs, program.cs, and it's got its weathercontroller.cs. Let's dive into the weather controller. And you're going to see these APIs are based on classes that then have methods with attributes on them. Great for building lots of APIs. But if I just want to build one API, I can go look at something like the Express application here, and look, it's very concise, down to 37 lines of code to build a single API. It gets right to the point. Now, if we move over to the new ASP.NET Minimal API, you're going to see it's even smaller and more concise than the Express application. 30 lines of code. And this is because we're using new features like top-level programs, global using, and lambdas to really reduce the amount of ceremony you have to do to write a single API. This kind of technology is great for building microservices and simple APIs. Now, as I looked at this, I wanted to compare all the technologies to each other. And so what I've got down here is I've got a notepad file, and I've kind of kept a tally of how much code you have to write. So the MVC web APIs, that's really if you want to build a lot of APIs, that requires about 138 lines of code to get started. The Node Express API uses 37 lines of code, and amazingly enough, .NET minimal APIs are only 30 lines of code. And this is just showing you we're applying these new technologies to make it faster and easier for you to build great apps. So here we are back in Visual Studio, and now what I want to do is run my app locally to make sure it works. Here we go, and you can see it's pulling the weather back, and so I've got a successful API using ASP.NET Minimal APIs running. Now the next thing I want to do is switch back to Visual Studio. Here we go. And what I want to do is I want to publish this application to Azure for the rest of the demos that you see today. So I'm going to click Publish. We'll select Azure, and we'll select App Service Linux. There we go. Let me create a new one. I'm going to change my name just to Minimal Weather. I've got a hosting plan already set up for me. I will select that. Press Create here. There we go. It's creating my app service. Now I'm going to click Next, and I'm actually going to deploy using GitHub Actions using CI/CD, and click Finish. What happens now is when I commit my app, it will do a CI/CD flow to publish it. I can switch to my repo, and you can see all the steps have happened to publish my app to Azure. And now I can actually go and open my browser tab here, and this shows the minimal API that we built running in Azure. And we will use this for the rest of the demos today.
Cool. And so I think that is some pretty cool tech you're going to enjoy. And as you can see, it compares very favorably with other technology stacks code. And so I think it's going to make .NET easier for some people to get started in. Next thing I want to talk about is .NET Multi-Platform App UI, or .NET MAUI. This is our cross-platform native UI stack that we have in .NET. And it's the way you should build desktop applications moving forward. It's got cross-platform native UI. What that means is if you're running it on Windows, it's going to use WinUI, the latest framework inside of Windows for drawing pixels. If you're running on a Mac, it's going to use something called Mac Catalyst. Mac Catalyst is a framework that makes it easier to port an iOS app to run on a desktop. It's how Apple writes some of their applications, and we let you do the same thing. It uses native iOS on iOS, and obviously it's using native Android on Android. Something else is it's a single project. If you've ever used Xamarin before, you had projects for each of the platforms you were going to ship to. In our case, we'll have one project for the entire thing. In the demo today, you're going to see it's a little hacky, but we hope to get there by the time we RTM in November. And you have one code base. So with one code base, you can target all of these types. You might be asking, is Linux coming? This is all we can bite off in this release, but we'll definitely look back and think in the future if we get feedback to think about Linux. You can deploy to multiple devices, mobile and desktop. You basically right-click on your project and tell it where you want to deploy it to, and it will do that. And it's going to ship in .NET 6. Something else that's part of this is tech we've been shipping for a while, but you might not know this. You can actually develop on a Windows machine on iOS. You can basically just plug a device into your Windows machine, like an iPad or an iPhone, and without having any licenses or any stuff like that, just a free Apple developer license, you can control F5 and F5 and run your application on your own devices. You don't need a Mac to do this. You only need a Mac to put something in the store. And so, amazing tech. So let's do a demo of .NET MAUI.
.NET 6 brings consistent experiences from all project types to .NET MAUI, including the command line. In this case, we're going to create a new MAUI app with .NET New MAUI. We're going to name it Build MAUI. Now from here, I could run, if I wanted to, .NET Restore, .NET Build, .NET Run, but I want to show you how we can build an optimized experience for building cross-platform applications with Visual Studio. So let me launch Visual Studio here. .NET MAUI targets iOS, Android, Mac, and Windows. And so what we're going to do here is take the single project here. We're going to set this to Startup Project here. And then what I want to do is I'm going to go to the debug menu here. And let me click that again, drop that down, and I'm going to select the framework that I want to run on. And I'm going to select Android here. And that means when I run the application, it's going to actually run the application on my Android emulator on the right here. So let's get this started. One of our goals with .NET MAUI was to give you a single project for building all your applications, so you can focus more on your application and less on the specific targets of your application. It all starts with the startup.cs file. This is very similar to what we do with ASP.NET today. This is where you configure all of the things for your application. In this case, we want Xamarin Forms compatibility. We set our default application. We're going to set our font right here. And if I'm using third-party libraries, I would configure them here as well. Maybe I'm going to use dependency injection. I want to share something across my application. I would put that here as well. And so that's kind of the way we copy that experience from ASP.NET to over here. Now we all have these folders: Android, iOS, Mac Catalyst, and we have the WinUI 3 down here. And this is where you write your platform-specific code. We also have a resource folder. Inside of that, we put your fonts, your images, your app icon, your startup screen, all in one place. And so here the application is booting up in my emulator. And what I'm going to do is I'm going to go and click the counter here. See, it's at number 5. And I'm going to show you a hot reload. I can actually change either my XAML or my C# and press save. And as soon as I do, the application updates immediately. This helps with your productivity quite a bit. Now this is a semi-simple application. Let's use a more complex example and show you how we can do platform-specific light up with .NET MAUI. So here I am in Visual Studio with my weather application. And you're going to see that as I run it here, it's a WinUI, native Windows application. But I've done a few things differently here. If you look in my configure services, I've added some new services. I've added a tray icon for putting a tray icon on Windows. I've added notifications for native notifications and a tray icon for Mac. Now, if I go and show my main page here, you can see what I've done is set up app actions. This allows me to put a context menu when you right-click on the app icon, where you can put some menu items in here and make it do some other options. I've also added a tray icon too. And so what happens here, if you click on the tray icon, we'll send a notification on the platform that you're on with that data. So if I look here, I can right click here, my new context menu showing up right here in my applications. It's showing native UI hookup. Here's my tray icon. I can click it and there you go. You can see as soon as I did that, a notification popped up in Windows. It's just showing how you can do these native light ups across all the platforms. Now, I can't just show you just Windows. .NET MAUI is cross-platform. Let's go to my Mac and I'll show you a couple other options. Here you go. I've got my same UI and same code running on iOS, macOS, and Android. If I resize the macOS application, you see it resizes dynamically like you would expect. If I click the icon, you see those same menu items there you saw before. And then if I click the icon at the very top, you'll get that notification directly on your Mac. So this is showing you how we can do this cross-platform light up, but still give you these native options with .NET MAUI, all using the same UI.
So I think that's pretty cool that you could basically write one code base, support all the different operating systems, and still do native light ups on those operating systems with the tray icons, the notifications, the context menus. You can do more. Let's talk about Blazor now. Blazor is our stack for building SPA type applications with .NET. You don't have to use something like React or Angular. You can just stay in .NET the entire time. So you can basically reuse UI components across native and web with this. This is showing Blazor running on the desktop here. So you can see that my typical Blazor app, but now I can run it on Windows and Mac as native applications. We plan hopefully in .NET 7 to support iOS and Android as well. And I said, you get to reuse your UI components across both native and the web. It's built on top of .NET MAUI, which is how it actually hosts. It's basically a MAUI application that has a Blazor web view control added to it, and that's how we display that. And because there's a native app container, it means your Blazor application has access to the entire machine. For example, we had a customer that was doing this for a dry cleaner, and they needed the app to have access to the cash register. And by wrapping their web app inside of a native app, they were able to do that. This is very similar to Electron. If you think about Electron, VS Code is an Electron application that's basically a web app sitting in a native host. Now you can write those same style applications in .NET. And once again, this will ship in .NET 6. There's tons of other Blazor features too. I'm not going to call them all out, but the big one here is, you might not know this, but if you run a Blazor WebAssembly application, we actually have an interpreter in the WebAssembly that runs your code. You'll now have the option to AOT, ahead of time compile, into native code to get native performance. We've also worked to make WebAssembly smaller. We shrink the size of the application. We've also added, I'll hit the last one as well. There's these fluent controls that that Microsoft has built. Primarily, it came out of the Office group, and we're going to have Blazor wrappers for those controls, so you can use those in your Blazor desktop application. ASP.NET Core gets a ton of new features too. We'll have a preview of HTTP 3. We want to make sure that we're always up on the newest standards, and so we'll be ready as soon as HTTP 3 is ready to go. We'll have it in our product. You can see higher throughput and less memory. Once again, we're always optimizing these things. We have support for OpenTelemetry, which is a great way of sharing telemetry across systems. You saw the minimal APIs that we did. We're making gRPC more resilient with retries and load balancing. And you can see we got some CSS isolation for pages and views, and better SPA support. So this is just a few of the features you'll see in .NET 6 and ASP.NET. So for this one, let's do a demo of some ASP.NET Core and Blazor.
Blazor makes it easy to build rich, modern web UI. Here's our weather app implemented as a web app using just HTML, CSS, and .NET. The web app has a nice responsive layout, so it looks good on mobile devices as well as desktop screens. We can see the current weather and local weather forecasts. We can also check out the weather from other locations. Here's the weather in South Korea. Here we can also change the settings of the app to switch from imperial units to metric units, and it automatically gets applied to the entire application. Now, all of the client-side interactivity in this app is implemented using reusable Blazor components that work in any modern web browser using just the open web. The app calls our Azure-hosted minimal weather API to get all of its weather data. By pairing Blazor with an ASP.NET Core server, you can build full-stack web apps with just .NET. Our weather app could still use some improvements. The list of weather stations on the right-hand side looks a bit plain. In .NET 6, we can quickly make changes to our ASP.NET Core and Blazor apps using .NET Hot Reload. Here's the component that displays each weather station. As you can see right now, it's got some simple markup. Let's update the styles for this stack box class. Save that. It gets automatically applied. Looks nice now. Let's also add some markup here in order to better lay out the text and maybe add an icon. Save that. With .NET Hot Reload, our changes get applied to the running app without losing any app state. Blazor makes building web apps with .NET fast and fun, but sometimes you need more than what the web platform offers. By combining Blazor with .NET MAUI, you can reuse your existing web UI logic and web development skills to build cross-platform native apps that can take advantage of the underlying platform. .NET MAUI comes with a built-in Blazor web view control that you can use to add existing Blazor components to any .NET MAUI app. This means we can take our Blazor components from our weather app and embed them into the .NET MAUI app without having to change anything. Here is our weather app running as a native desktop app on Windows. It looks the same and has exactly the same functionality using the same Blazor.NET code. Blazor components hosted in .NET MAUI run directly in the .NET process. This means they run fast and have full access to the native capabilities of the device through the .NET platform. For example, we can reuse the same system tray integration that you saw previously and trigger native platform notifications. Because this Blazor app is running inside a .NET MAUI app, it can run on other platforms too. Let's switch over to my Mac to see how Blazor desktop app can run cross-platform. All right, here is our Blazor weather app running as a native Mac app. As you can see, it's got the same look and feel. It's got the same functionality. If we check out the weather in South Korea, we can do that. There it is, and it looks and feels the same because it's the same code that we ran in the Windows app and also on the web. The app also has native integration, so it can show the little .NET bot up in the menu. We can click him and trigger a native notification. By building our app as a Blazor hybrid app with .NET MAUI, we get the best of .NET, the best of the web, and the best of the native platform.
Cool. And so the final one that I want to talk about is inner loop. And this is a term that we use inside of Microsoft. And what inner loop means is this is how long does it take you to make a change and see it reflected in your application. So we've done a lot of work in .NET 6 to address this. We always have had great runtime performance in .NET, but we've not had great design time performance. And so we're trying to fix that. You can already see here, just the build performance is already faster. We've worked to make the build performance way faster in .NET 6. We plan to have hot reload everywhere for all project types, whether it's WinForms, WPF, .NET MAUI, ASP.NET, Blazor. We want it to work everywhere. We're not going to require you to restart the application in most cases. You could be able to make some changes without restarting the app. You just make a change. You'll see it reflected in the application. No restart of the app, and no attaching the debugger either if you don't want to. You can optionally add the debugger to it after the fact if you need a breakpoint. And it's an evolution of edit and continue. We're making edit and continue much better. We're going to go and take some of the newer C# constructs that you cannot change in an edit and continue app today and make them work. And so I think you're going to be super excited by this. And let's do a quick demo and see what the hot reload looks like.
For this demo, I have two apps to show you. First, let's start with the WPF app running on the right-hand side. This is a .NET 6 app called Voids, a game of life simulator, and you can see many shapes moving around. With .NET Hot Reload, we can now change the game logic while the app is running. To do that, we're going to press this brand new button. Now let's go ahead and make a change to the app and see how it works. I didn't build the app, so I'm not sure what changes to make, but let's go ahead and change speed limit. That seemed like it's going to do something. So I'm going to go ahead and change that. How about we add 10 to it? Now I'm going to apply the change, and as you can see, the behavior of the game is changing right away. I'm going to undo that. I'm going to make a different change. I'm going to make a change to the percentage to move towards home. Not quite sure what that's going to do. Let me just add 0.1 to that. And again, I'm going to apply the changes. And now you see a dramatic change in the app without having to restart it. While it's fun to show you an app like this, I now want to go back to our weather app and show you some edits that should feel like real-world situations. Let's switch over to our weather app. Here's the weather app you've seen in the other demos. As you know, this is a .NET MAUI desktop application, and here too we can apply code changes while the app is running. So first I'm going to look at the wind indicator. I expected some simulation code to have been added to make the indicator move. Let's go ahead and see what happened. I'm going to go look at the code and find there's a to-do here. Instead of stopping the application, I'm just going to go ahead and add the code that I would have expected to be here. I'm going to add a get direction, which gives me some random directions. I'm going to change it so it applies the direction icon, and I'm going to apply those changes. The indicator starts to move. For favorites, I'm going to go ahead and click that button. And it seems like something is missing here as well. So let's go look at the view model. Well, I have some properties here, but it seems like I have no logic to load the data. Let's make a change that's needed. Now I could have typed this, but just to save us some time, I'm going to paste the code in. It should have been here. And you can see we have a constructor, an async method, a private method. All of this can be applied to the running app by hitting the apply code changes. Switching back, I can go ahead and switch to the home screen, switch back to favorites, and now I see the data. But I see one last bug. It's only loading Redmond. Let's go take a look. Yes, would be easy to miss. It should be an I instead of 0. I'm going to apply those code changes and navigate back and forth. There we go. And now we get all the data we expect. Now with this app, it easily could take 15 to 20 seconds to restart the application, and it's a small demo app. But with Hot Reload, we were able to make all these changes without having to restart the app a single time. Imagine how much time it will save you.
Cool. And so that is .NET Hot Reload. .NET 6 Preview 4 is available today. As I mentioned before, .NET MAUI is now supported in Visual Studio. You can build your Blazor hybrid apps. Minimal APIs are there as well. Please go and grab .NET 6 Preview 4 and try it today. Give us feedback. Remember, you can install this on a machine and it will not break your existing .NET 5 or .NET Core 3.1. That'll still work. And then ML.NET, this is our machine learning library. We've added some great new features to it as well. So we now support ARM64 and the Apple M1, which means you can use ML.NET models on all the devices. Something else we've done is when it says config-based training, basically we have this thing called Model Builder that you see on the screen here, and it will help you build your model and write your code to use ML.NET in your application. It used to be this was a one-time run tool. Now you can re-enter the tool and it will save all your stuff. If you want to import more data and train your model better and so on, to learn more here, dot.net/ml will get you there. And then of course, I have to announce that we will ship .NET 6 on November 9th this year. It'll be our launch, and we always have a .NET Conf that goes with that, and that's a 3-day, half Microsoft, half community event, and we will show you all the new stuff in .NET 6, Visual Studio 2022, and all that stuff. So please come and find us and join us there. And I want to thank you so much for letting me come and speak at CodeGarden. I cannot wait to see the release of Umbraco 9.0 that's going to run on top of .NET 5. Super excited about that. Grab the preview, read about our previews, go grab that Umbraco 9 alpha or beta and try it out as well. And I'm going to be around for a couple questions. Thank you.